Hello, I'm Mark Riley, the head of the Department of Biological Systems Engineering at the University of Nebraska, Lincoln. Our department is the home of the Agricultural Engineering undergraduate degree program. Our program has been in place since 1908 in Nebraska. Our program serves the needs of a very diverse industry, both in Nebraska, regionally, and also internationally. So I'd like to tell you a little bit about our program, the activities, the classes, our faculty, and our staff. So the Agricultural Engineering program is housed in Chase Hall, which is on East Campus in Lincoln. So we have a beautiful building at the end of the mall on the western part of East Campus. Myself, I'm the professor and department head, and I've been here since 2012. I was raised in southeastern Michigan. I went to school at the University of Michigan and at Rutgers. I was on the faculty at the University of Arizona for about 15 years and came to Nebraska about 2 years ago. The reason I came here was because of our program. The program in agricultural engineering is truly one of the best in the country. We prepare students for a diverse range of industries. Our faculty are tremendous, and it's a wonderful environment for the students to gain education, to be prepared for entrance into the workforce. So myself, my research and my teaching has focused on bioprocess engineering. And specifically, our work has been to develop sensors to detect pathogens and viruses and bacteria in the environment, specifically for drinking water. So the BSE department, located on East Campus, not only has facilities in Chase Hall, but also in Splinter Laboratories. And this is the home of the Nebraska Tractor Test Laboratory. So you can see the oblong track, which sits just south of Splinter Laboratories and just north of Chase Hall. Our students have activities in both places. So agricultural engineering has been named as one of the most important components of our global society. Several years ago, the National Academy of Engineering listed the top 10 most important engineering achievements of all time, and mechanization of agriculture made that list. In just a few generations, we've gone from brute force activities using the power of animals and man to be able to generate the food to feed our country and the world, to now using a variety of technologies and innovations to mechanize how we produce food, to do this in sustainable ways, to reduce the amount of labor on the farm, and to overall increase the productivity and stability of producing food, fiber, and feed. So why would one want to become an agricultural engineer? Well, our challenges are only going to continue to increase. We'll need to feed roughly 9 billion people by the year 2050. That's a substantial growth in the number of mouths to feed. We're not going to do that by finding new land or finding new water, but what will have to happen is for us to become more efficient in how we use our land and how we use our water. The inputs need to be monitored much more closely than they have in the past, but we also need to meet the needs of producing energy interlaced with our food production. And this is going to be done by developing new technologies and developing new systems that integrate these technologies with meeting the needs of the communities. Forbes magazine recently reported that agricultural engineering is one of their top 5 majors for the class of 2012. This major involves utilizing our increasingly scarce resources to increase our productivity. So what's happening today? So there are tremendous advances that are being made in the field, and our faculty and our students at Nebraska are playing a large role in this process. One component is the development of autonomous machinery, or robots, utilized in agriculture. So we're not at the point where we would have robots moving without human intervention. However, they help to increase our productivity. Advanced machine controls allow us to manipulate our inputs to the field, to monitor what we're doing, and to be much more efficient and effective. A key component of this is the use of what's called variable rate application technologies. So this not only is used to monitor and to be very precise in our planting and fertilizing, but it's also in our water management, so we can get more crop per drop in the field. So a great example is this prescription map shown on the screen here, where we can look at soil composition and deliver the nutrients and the amount of seeds that's needed for that location. So a key part for agricultural engineers is interfacing the technologies, but also understanding information. So it's no longer enough just to collect information. We need to know how to use this to make better decisions. And that's a key role for engineers. So variable rate agriculture is possible really through integration of a wide variety of technologies, from GPS to rate controllers to telematics to valves and actuators. And they can utilize the information from these prescription maps to be very precise. So to reflect the diversity of the activities that our students do once they graduate, our agricultural engineering program has three main options. So all of our students take core coursework in agricultural engineering. These include some foundational courses such as statics, dynamics, e-bodies, and thermodynamics, but also science-based foundation courses, math, physics, chemistry, and biology. And our students get into some of the discipline-specific application areas, including instrumentation and controls, engineering properties of materials, and process engineering. It's very important for our students to gain hands-on experience, and we provide many opportunities within the classes to be able to gain such experience. For more information on our academic resources, follow the link below. So our emphasis areas within agricultural engineering are machine design, test engineering, and soil and water engineering. A little bit about each of those. So in machine design, our students can take courses in kinematics and dynamics of machinery, and dynamics and control of engineering systems. The test engineering emphasis is closely aligned with the machine design emphasis and includes site-specific crop management and equipment and tractor testing. The third component of our program is our soil and water emphasis, and this includes developing irrigation schemes, environmental engineering, and animal waste management. Our freshman and sophomore advising is performed by two faculty, Dr. Roger Hoy, who is the director of the Nebraska Tractor Test Laboratory, and Dr. Michael Kocher. Dr. Kocher is the chair of our Board of Engineers for the Tractor Test Laboratory. So they alternate years in terms of taking freshmen and sophomores, but both of them provide excellent guidance for our students to help them understand which emphasis area is best for them, help them select classes, and give them direction for gaining experience through internships, clubs, and other activities. So the opportunities for our students are really quite tremendous. If one is interested in agricultural engineering, Nebraska is certainly the best place to be pursuing those studies. We have tremendous interactions with industry. They participate in our senior design projects. They also support our students in numerous ways. One recent example is providing support for our students to go to some professional machinery conferences. So we also have a very active series of clubs within our program. The quarter scale tractor program is run through a professional society called the American Society of Agricultural and Biological Engineers. This past year we had two teams participating in the competition in Moline, Illinois, and one team finished 8th out of 25, and the second team finished 4th out of 25. So we're very proud of our club. They do a tremendous job in building a quarter scale tractor that you can see here, really from the ground up. Each year they start from scratch and develop their own design. They work closely with our engineers. They build and they test, and then they compete. So our department is very fortunate that we have quite a number of scholarships that are available to students. For more information, follow the link here. So our department is operated through both the College of Engineering and the College of Agriculture, and this provides more opportunities for these scholarships for students. So currently we have 23 named scholarship funds. That the funds have been provided by donors specifically to be able to support students. Some of these scholarships are need-based and some are renewable. So for more information, follow the link and submit an application in order to meet the deadlines. So there are many ways to stay connected with Biological Systems Engineering Department, from student clubs and a variety of department activities. We have a Facebook page and a LinkedIn group. You can also follow along activities that are listed on our website below. So after one gets a degree in agricultural engineering, a great question is, where will they work? There are tremendous opportunities for jobs in agricultural engineering, especially in Nebraska and the surrounding states. So not only do we have many of representatives of machinery companies coming to visit, specifically in connection with the tractor test laboratory, but also Nebraska has more acres of irrigated agriculture than any other state in the country. And in strong correlation to this, we are the home to the 4 largest irrigation manufacturing companies in the world. So we have strong connections with industry. The industry representatives are coming to visit us on a regular basis. They're offering internships for our students, offering full-time activities, and there are tremendous opportunities for jobs in agricultural engineering in Nebraska. So while you're in school, make sure that you do apply for scholarships. You can't get scholarship dollars unless you apply. Internships are tremendously important. Many companies are hiring students after their sophomore year as a test run to see if this is someone that they would like to hire after the student graduates. So do internships as early as you can, get involved, get engaged, get that experience. Starting salaries for ag engineers is quite strong, but the salaries really depend on the size of the company that someone goes to work for and also the location. And many firms do have international opportunities, and agricultural engineering across the globe is an increasingly strong job market. So ag engineering is in demand, but a key thing is that our students learn how to solve real-world problems. They integrate knowledge from the engineering foundations of mechanics, hydraulics, and electrical systems. They understand how these interface with agricultural production, and they take a systems approach, which really is looking at how to connect the different pieces and make something that's better than just the individual parts working in isolation. So thank you for your time. If you have any questions, do not hesitate to contact me. Again, I'm Mark Riley, the department head from Biological Systems Engineering, or contact Mr. Revan Curtis, who does much of our student recruiting and student advising. Thank you for your time.